So very good day everyone. So today we'll cover the basic concept of the neural network, which is the foundation of the structures and evolution of the structures from the biological to the artificial. So basically in today's lesson, I will divide the parts into three parts. The first one is the introduction to the biological neural networks, in which how our brain works, and then the smallest particle inside of the brain, and how it can be utilized in order to do the some sort of the human activities such as recognition, perception, and etc. And then the second thing is the introduction to the artificial neuron. So this is the process how we transform from the biological neuron to the artificials, which is in terms of the mathematical model formulation. And then finally is the introduction about the artificial neural networks, in which artificial neural networks is the interconnection of many artificial neurons in order to solve more complex problems. So now let's get started. So basically for the artificial neural networks problem, so one of the simplest aim is that to utilize such structure in order to do the classification task. So for this particular case, let's say we have the 5 types of patterns, so in which we want to develop a classification model using the artificial neural networks to classify each of these type pattern. So let's say if the input is the 7 dimension, and then the output will be 5 dimension in terms of the tagging. So for this particular case, if let's say we give the tagging of our input F1 to F7, which is 7 bit of the pattern that will be used in order to extract features from each of these 5 types of pattern. And then secondly, in terms of the output, let's say we put the 5 dimension output as the label. So for instance, for this case, the star will be 0, 0, 0, and then square will be 0, 0, 0, 1, circle 0, 0, 1, 0, and etc. So let's say this is some sort of the set of our input and output label. So if we extract the different type of features for this particular pattern, so let's say for the first pattern, so this is the 7 dimension of features that we extract from this particular pattern. And then the same thing for the square. So for this case, square only have 2 types of values from the 7 dimension. The same thing for the circles, and then for the circle plus cross, and also circle plus rectangle. So let's say this is all type of our features extracted from this particular pattern, and we give the same tagging in terms of the output. So the issue is that how we able to find the mapping relationship between input and output for this particular condition. So how we able to relate input and output for this case in order to ensure that when we fit in another type of pattern, it will give some sort of the prediction or estimation of the output. So let's say if we try to simplify that problem into the much simpler representation. So let's say in this case we have just 2D of input, 2 dimension of input, and one dimension of the output. So let's say for this particular case, if our first sample, the input will be 2, 6, and then the output will be 10, and also the second samples, the input will be 3, 9, and then the output will be 15. So the issue is that what will be inside of this black box, which is remain unknown. So in general, for the statistic or based on the mathematical model, if we able to gain some hint about the relationship, so we can actually determine the equation. So let's say for this particular case, if we put the first dimension label as the x, and then the second one will be y, and then the output will be labeled as o. So for this particular case, if we look at the representation of the samples, input and output, so for this particular case, we can say that 2x plus y equal to o. So this will be our general equation that can be utilized in order to map between input and output. We can try that thing. So let's say 2 times 2 will equal to 4, and then plus y equal to 6. So the output will 10. So the same thing with the second sample. So this is usually the way on how we are able to relate between input and output. So how neural networks utilize its capability or its model in order to solve this thing. So neural network can solve this particular problem by using the simple structure. So the same thing with this particular case. So for this particular case, in general, neural network can be utilized in order to solve the same problem by using this simple structure. So in this simple structure, it has some sort of the summing part and then the activation part. So the most important parameters for this case is this part. So in every model of the neural networks, you need to actually estimate, or you need to actually predict the optimal value of the weights by using the training process. So in general, for this particular case, for whatever type of problem, we can use the same model of neuron, only we need to find the different type of the pattern. So that's one of the reasons that we call the neural network as the universal function approximator. So it means that for every other problem, we can still utilize the same structures. Maybe we just add 2 neuron or 3 neuron, and then later on, by using training, by performing the training process, we can estimate the weight value, and then later on, by after the training and then some sort of the tuning, it can be used in order to solve the problem. So let's see, for this particular case, how the neural networks can be used in order to solve our previous problem. So we have the input is 2, and then the 2, 6, the first sample, and then the output is 10. So how the neural network solve this thing is 2 times 2. In this case, for the first part of line, we have a value of 4, and then the second one is 6 times 1. So the output here will be equal to 6. So this will be the summation point. So the aim is just to sum up everything. So in this case, 6 plus 4 will be equal to 10. So we pass the value to the next part. So for this case, for our activation will be the linear function. So it means that for the linear function, output will be equal to input. Output will be equal to input. So in this case, our input is 10, and also the same thing with our output. So this is the process how the neural network can be used to solve the given simple problem. So if we try to look back of the first problem, which is the bit complicated problem, in which we have the 7 dimension of input, and then we have the 5 dimension of output. So let's go back to our first question on how we are able to relate between input and output. So if we try to find a hint, what is the type of equation that can be used, maybe the quadratic polynomial, so it will be very hard in order to approximate the function. So in this case, how we can utilize the neural networks in order to solve this thing? We can actually use the same concept in which previously we just used single neuron. But in this case, since the problem is a bit complicated, we can add multiple neuron and then make interconnection between each of the neuron, and then we fed the same input and output, and then do the training in which we find the optimal weight in this part. So eventually this model can be utilized in order to find the mapping between input and output. So along the way this class session, I will show you some sort of the example that I have construct in order to solve this problem by using the simple neural network structure. But basically this is the basic concept of artificial neural network and how it can be utilized in order to solve the real problem. So one of the beautiful part of the neuron, since previously we see we have a lot of the neuron in every layer. So how the neural network can be utilized in order to perform the classification is based on the optimal selection for every type of the neuron. So let's say for this particular case, so we fed the input image of the cat. So not all the neuron in every layer will be activated at one time. So it will be activated based on the activation function, whether activation function will be triggered by the value of input that it has received from the previous layer. So by using the selective activation for every type of the neuron, so it can be utilized in order to estimate whether this type of input image is cat or not. So this is the some sort of the illustration on how the neural network selective model will be activated to predict some sort of the output. So now let's we go back to our first three main topic, which is in terms of the biological neural networks, and then artificial neuron, and then the artificial neural networks. So basically for this part, the first part, which is the biological neural networks. So basically for the human brain, it will be comprises of the three main system. So the first one is the receptor. Receptor is our senses. Let's say based on the eyes, based on the ear, based on our tongue, which tastes everything. So the brain will receive input from the receptors, and then later on it can give some sort of the output to the effector. Effector is some sort, let's say, the movement of our arm, the our reflection type, and etc. So this is the process on how the human react based on the based on the given input, and then what type of the output that will be produced based on the sense of the receptor. So our human brain, each part of the our human brain will be utilized in order to solve some specific part. So let's say at the back of our brain, so the aim is this part will be utilized in order to visual perception, and then let's say this part will be the sensor motor area, which is how we move our hand or legs. So each of the specific part was dedicated to a specific function. So our brain will constitute of many type of the what we call as the neuron. So in this case, theoretically it will be about 10 billion of the neuron. So neuron is type of the features that will be utilized in our brain in order to perform some sort of the reaction or reflection based on the given input. So the same concept. So let's say your vision, your eye sense something, and then our brain, based on the logical of the receive input, if we give some sort of the reaction, whether we need to move our hand, whether we need to close our lid, or whether we need to move our leg in order to react with that current situation. So since our human brain consists of the billion of the neuron, so let's just focus on the single part of the neuron. What is actually the neuron? So we try to zoom at the smallest particle of our brain, which is the neuron. So basically the neuron will be comprises of the four main parts. So the first part is the soma, which is the cell body. So this is the part of the soma, which is the whole structure of the neuron. So the second one is the dendrite. So dendrite for this particular case is the input, which receives some sort of the value or information from the senses. And then the third thing is the synapse. So synapse is some sort of the small connection between your input and the soma, which is this is the part that will be utilized in order to trigger, in order to decide whether the output should be triggered or not. And then the final part is the axon. So for this case is the one that will be plugged in to our output. in order to control the motion, movement, or reflection, and etc. So this is the four types of components that was actually inside the human neuron. So for this type of the neuron, so how we able to translate this thing into the mathematical model that we can utilize later on in order to solve some complex problem. So for this particular case, all the dendrites will be translated to the series of the input in our neuron. So the second thing in terms of the cell body, which is soma. So the cell body will be the whole structure of this part of the artificial neuron. And then the third thing is in terms of the synapse. Synapse will be, in this case, synapse is actually the way between of the input path to the between the input path to the body of this thing. So we have the synapse that will be responsible in order to either to trigger or either to not trigger in terms of the output. So finally, for this case, the axon. So the axon is the second part. So if I can label, so this is the type of the axon. So this is the synapse, and then this thing will be the dendrites, and then the whole structure of this thing we call as the soma. So this is some sort of the labeling from the biological neuron to the artificial neuron, in which for this case soma will be the neuron, dendrites will be the input, axon will be the output, and then synapse will be the way of connection. So for the artificial neurons, so in general, the basic concept for every of the neuron will be comprises of the two parts. So the left side of the part, which is the summing point, so the aim is that whatever input that we receive from the multiplication input and then the multiplication of the input and weight, so the left side of the neuron we just sum up everything, or usually in labeling we just put some sort of the summing symbol. So the aim is simple. So whatever input here multiply with the weight, so it will just sum up everything here. So in general this will be the equation for that thing. It's quite straightforward. It's very simple. Means that the summation of the weight multiply with the input, the multiplication of that thing, the summation of multiplication of input and weight, so will be in the left side of the artificial neuron. And then the second part is the activation function. So the activation function is some sort of the function that will be utilized in order to ensure whether this type of neuron should be triggered or not. So usually for the activation function, we can use many type of the activation function. Let's say the threshold function. Let's say higher than some specific value will be triggered, lower will be not triggered. So the signal function will be something like the probability of the output. So the same thing with the step function, but the step function will be something like the hard limiter function. Ramp function, this is the straight line. So this is the step function. And then unipolar sigmoid will be something like the S, and then the same thing with the bipolar sigmoid. So this thing will be the probability. So this thing threshold function and step function will be the something like the hard limiter, which is either 0 or 1, whereas the rest will be based on the probability between 0 and 1. So another important components of the artificial neural network. So basically, previously, if you still remember, so this is the basic type of the neuron, in which the left side will be the summation and then the right side will be some sort of the activation. I just put, let's say, the activation symbol, in which we have the some series of the input, let's say x1, x2, x3, and then later on the connection line between input to the neuron, and then in between of this thing we have the wake. So let's say this is wake 1, wake 2, wake 3, and then we have the output part of the neuron. So this is the basic component of the neuron. So bias is just some extra line we plug into the neuron with the value of 1 in general. So, and then we put some sort of the value p here that stands for the bias. So this is some sort of the constant value that we can obtain from the training session. So why we put the bias? So in general, bias will be useful in order to add more flexibility in order to perform the classification task. So in the simple analogy, so the bias will be something like this. So if let's say we have the equation of line y equal to mx. So if we draw this thing, so means that our line will be bound with respect to the origin. However, if we say y equal to mx plus c, so if we have the c usually in the straight line is the intersection point in terms of the y-axis. So c in this case is something like bias. So if you just without bias, so means that the constructed classifier line will be bound with respect to the origin only. However, if we put some sort of the bias, so means that we have the flexibilities, either it can be some sort of in this point in order to perform the classification. It can be either in this location to do the classification, or it can be either in the origin in which the C or the bias will be equal to 0. So it means that if we add the bias, in general we add more flexibilities to the classifier in order to perform the classification task. So this is one of the aim we put the bias in the neural networks. So the final part in terms of the introduction will be the artificial neural network. As I mentioned previously, the artificial neural networks means that we have the interconnection with many type of the neuron. So let's say previously we have neuron here, single neuron with the activation function. We have some sort of the input x1, x2, x3, and then the connection of everything here. We have the weight, and then we have the output, and then we can add some bias. So the artificial neural networks means that in a situation that we have more than one type of the neuron in order to perform the classification task. But one of the things that we need to remember, so all the inputs will be connected together. The bias will be different for every type of the neuron, and then everything will be connected together with different type of weight in this part. So this is the meaning of the artificial neural networks. So it means that we have more than one neuron, and then we make the things fully connected between each other. So then it can be utilized in order to solve much more complex problem. I will show you later on in the next lecture what is the difference between we just use single type of the neuron and we add multiple neuron in order to solve more complex problem. So for the artificial neural network connection, so it can be the connection of the artificial neural network, it can be in two ways. The first one is based on the feed-forward networks, and then the second one is based on the feedback or the recurrent networks. So feed-forward means that it will be one-way process, means that we have from the input and then to the output, and then it will be connected, fully connected between each other, between each of the neurons. So this is the feed-forward connection. And then the second thing is the recurrent connection. Recurrent connection or feedback connection means that this is we have the two-way flow, means that this is the first way flow, and then we have the back wave flow. So it means that for this case, the output will be feedback to the input later on. So this is some sort of recurrent connection. So for the recurrent connection, it will be usually used for the some application of the speech recognition. So something like connected between the continuous function. So in order to construct the model of the artificial neural networks, so there are many ways to do that thing, but I just simplify the more dominant ways in order to construct these artificial neural network models. So to develop this model, so we need to know what type of the activation function for every type of the neuron. So this first thing. So I've mentioned previously, we have many types of the activation function. Either it can be threshold, it can be the step function, sigmoid, and etc. So the second one will be based on the number of the hidden neuron for each of the layer. So in a situation, so how many neuron that can be useful or it can be utilized in order to solve some sort of the problem. So this is some sort of the design process in which we add or we increase the number of the layer, we increase the number of the node, which is the neuron, in order to solve more complex problem. But the question is that how much of the number of layer or number of node of the neuron that can be utilized in to solve that particular problem. So there is some sort of the design specification. And then the third thing is what is the best or what is the optimal learning and training rules in order to solve that thing. So this is some sort of the function or the content that you need to bear in mind when you try to construct your own artificial neural network model. So the first one is based on the selection of the activation function. Second one is simple, how many hidden layers, how many hidden node, or how many hidden neuron that you need to use. And then the third thing is what type of the learning function or training rule that will be utilized to optimally solve the given problem. So for every neural network structure, so you have two phase in order two type of phase in order to assess the performance of the model. So the first one is based on the learning process. Learning process is the process where neural network will be trained. So this is some sort of the, in a simple layman term, is somewhere you memorize the thing. I give you a lot of input, so you try to memorize that thing. So let's say I give the picture of apple, orange, and everything. You just try to memorize this is apple, this is orange, based on the given input. So the second one is the recall. So recall, this is the most important parameters that you need to remember when you tune your performance of the neural networks. So recall is the way that you feed with the new type of input, and then how you can utilize the previous training process that you have memorized in order to construct this thing. So let's say in a simple way, in the learning process, maybe you'll be given some sort of the set of rectangle, something like this, or something like this. So this is all the thing that you need to memorize as the rectangle. So in the recall phase, so you might be given some sort of the rectangle, but will be much more bigger or in different orientation. So so the issue is that, is you able to let the computer know that this is still a rectangle, even though the dimension is a bit bigger, even though it will be in the different type of orientation. So if you are able to ensure that your model able to still recognize this is a rectangle, so it means that your recall precision will be quite high in order to solve that particular problem. So usually when you perform the training process, normally you can gain the 100% performance in terms of the training, usually, or it will be something like 90% and above. So however, your performance or your model accuracy will be highly depending on your recall. So if let's say you have the 100% performance, but you just only have 50% recall. So in this case, we can say that your model is not good enough in order to recognize new things because of course, right? You just know how to memorize. Let's say I give you the A and then I give you the same A. You can remember that thing. If I change the size of the A or I rotate a bit the A, you are able to recognize that this is the A. So that's the thing regarding the recall. So what you need to ensure that you need to ensure, let's say, this performance in comparison with this type of performance, let's say you have the 90% in terms of the learning and then you have 85% in terms of the recall. So this type of model will be much more better than this type of model because of what? Because of you need to ensure that you're able to memorize the thing in the high accurate, and then at the same time your recall is more important because of everything in the neural network model will be tested with the unseen data. Because usually you have, let's say you have some database 5,000 etc. You train that thing with your 5,000, but the most important thing is that when you try in a real application, so is it based on the training set that you have given to the model, it's able to recognize new things, new item. So that's the way we know that your model will be good enough in order to utilize in a real application. So this is some sort of the application of the artificial neural networks. It can be something like the pattern recognition, signal processing, natural language processing. In control system, it can be utilized in order to learn type of the error, delta error, and then how it can be used in order to projection of the delta U. The same thing with the system identification, means that you don't know what is the mapping between input and output, the black box problem. So how we able to relate or how you find the optimal mapping between input and output by using the optimal function approximators, means that you don't need to know what type of the relation, let's say, is based on the quadratic, based on the polynomial, or with the higher polynomial power, but you just put the same structure. We just need to add the number of the neuron, add the number of the layer, and then perform the training process, and then eventually it can be utilized in order to find the optimal mapping between input and output. So this is some sort of the application of the artificial neural network. It's just a simple example, but to give you some sort of the hint, the application of this thing. So this is the first application in which it can be utilized in order to recognize various type of shape. So in this case, let's say we train the things in order to recognize the number of types of car. So car, or we fit the number of the car, and then it will be mapping every type of features of the car, and then eventually we give some sort of the output with some sort of the probability. So usually the highest probability will be belong to the input that you fed to the model. So this is one application. So second thing, so this is we call as the detection process, in which detection is the process we recognize the type of object, and then at the same time we give the locality of the object instead of the image. So this is some sort of the example. So it can be utilized in highly overlapping condition with a different type of scaling, different type of the image dimension, and etc. Because it's more robust to that particular thing. And then we give you some sort of the probability. Usually you need to set some sort of the threshold to set that whether this is let's say after higher than 0.5, so it will belong to that particular set. So another example will be in this case is the car damage for the this is for the insurance companies. So it means that the application will be simple. You just need to snap picture of the damage inside of the car, and then they will give some sort of the prediction. So based on this case, based on the number of damage, so if we predict what is the amount that the insurance company should pay in order to recover the damage of the car. So that is in terms of the basic just introduction of the convolutional neural networks. So along the way, in the next lecture, I will give you more on the mathematical models, how we're able to train the simple model of the artificial neural networks. And then later on, once you master the art of a single neuron, we will increase the number of the neuron to the multiple type of the neuron, so that you can solve more complex problem. And then later on, if after we finish up in terms of the second part of the multi-layer perceptron model, multi-layer model, so we move on to the next chapter, which is more complex, which is the convolutional neural networks and how it can be used in order to train, to extract features from the image, and etc. So that's all for your first class session. So hopefully you can enjoy your class, and then give some sort of the exact answers in your form later on. That's all. Thank you very much.